Hello and welcome to Season 2, Episode 7 of LogiCast, the AWS News Podcast brought to you by Logicata. I'm Karl Robertson, CEO and co-founder of Logicata, and I'm joined today, as always, by my colleague, John Goodall. How are you doing today, John?
Looking forward to the weekend, because for a change we're recording before the weekend instead of after, because I get to dig another hole.
Well, we used to always do it before the weekend, and then we moved it to after the weekend, but we've just gone back to a before the weekend for today, just to confuse everyone, including ourselves. So what are you digging for this weekend? Are you back on the pruning?
Pruning's done, everything's out, so now it's levelling, because my garden's on the slant, so that I can get a base down, so I can put a shed on it, because, you know, this is shedcast.
Shed hour, yeah. I tend to say every week that we're not here to talk about sheds, we're here to talk about AWS. But actually, if you're a regular listener to the podcast, you'll know that's simply not true. We probably talk about sheds as much as we talk about anything else. I was once bought a book actually called Men and Sheds because I lived in a house like you, John, and I think at my peak I had 4 sheds in that particular house, which most of my friends found rather amusing. So I thought it'd be amusing to buy me the Men and Sheds book. I must dig that out, and perhaps I can share it with you. It'd be an interesting read for you.
Well, this is going to be shed number 3 that I'm putting up, and technically one of them isn't a shed, it's one of those like plastic storage boxes, but it's like 6 and a bit foot tall, and it's not quite a shed, but it's like a storage unit thing.
I'll allow you to call that a shed.
It's got shed things in it. It's got the lawnmower in it.
If AWS Outpost can be considered as cloud, your plastic storage box can be considered as shed. Anyway, that's a nice segue. Nice segue back into the world of AWS, because the primary purpose of this podcast is not to talk about sheds and gardening. It is to talk about AWS news. So once a week, I curate a list of AWS news, which I share in my AWS News Roundup newsletter. Then John and I handpick a subset of those articles which we would like to talk to you about. So we have such a similar set of articles this week. The first one is on the AWS Compute blog, and it's entitled Scaling an ASG, an auto-scaling group, using target tracking with dynamic SQS target, or with a dynamic SQS target. I nearly got the title out without messing it up. Yeah, tell us more, John. Why might one want to scale an auto-scaling group using target tracking with a dynamic SQS target?
Just for something to do on a Friday afternoon. So, yeah, fun topic, this one. So, what most people think of when you think of an auto-scaling group is then a target group and load balancers, yeah? Because you're scaling a website to meet demand. What you can also do, however, with scaling is run asynchronous worker processes. You see this a lot more in like the Rails community and that kind of thing, because they're sort of used to that. And in AWS land, sort of the recommendation is, where possible, do it through Fargate or do it through Lambda, because then you just don't have to worry about provisioning and things. But in some cases, that's not always possible. Maybe you can't get a Docker image small enough that Fargate or Lambda will work with it. Maybe it's prohibitively expensive to do it with Fargate for one reason or another. Maybe you've already got this set up with servers and you're just kind of in that lift and shift phase, but you want to take advantage of the scalability of the cloud still, which is absolutely a thing that you should be doing. So you can use this to process asynchronous jobs based on the demand of the job. The common example is something like processing user-generated content, right? You need to validate that there's not anything that breaches your terms of service. You might want to run AI against it, put it somewhere, do tags on it, all those kinds of things. So the job is, service comes in, we're looking at a particular task. We've got a whole queue of these queued up, and rather than things just sitting there and churning away and it kind of backing up and backing up and backing up, you have a target that says, when you get to 100 jobs deep, 500 jobs deep, whatever AN number, bring me another server on, so that those servers are pulling things from that SQS queue, processing them, and then grabbing the next one, and so on and so on, so that when you get this big influx of things into that queue, you scale up to process the queue, and then you've processed that big spike, and then you scale back down again to your tick over level. if you like. What it's doing is it's, I believe the term is smoothing the spike, leveling the curve, to use that old NHS analogy.
Yeah. So the article goes on to talk about how to build all of that, but I guess you need to know what good looks like. So it's got some lovely formulas in here, how to calculate your BPI and your acceptable BPI. The backlog per instance and the acceptable backlog per instance. I guess you obviously need to know what good looks like in terms of how quickly you're going to be processing these batches of tasks. So.
This was a lot more prescient until, I think, like within the last month, because very, very recently you've been able to control the scalability, not the scalability, the number of Lambda functions concurrency based on the depth of an SQS queue. Yeah, that has only come on in the last couple of weeks. So for this particular workflow, maybe this one isn't the best anymore, but like I say, up until very recently, this was sort of the best option.
Yeah.
I'm also quite interested in, have they used the right icons, Karl?
Well, I was just about to say, I've scrolled down to the diagram, which is more complicated than I thought it would be, frankly, for this solution, which sounded quite simple, but it does seem to have more components than one might expect. Just excuse me a moment. Sorry about that. But the only ones that look like legacy icons are those metric ones, and I'm not sure they're actually service icons. So, they are in the legacy 3D style, but I think I'd probably let them off with that because the actual service icons are the current generation.
I'm annoyed that they've used the grayscale ones for most of it, apart from the SQS queue.
Well, I suppose that's to highlight what the and the ASG. They're both in colour, and that's what the article is about. So that's actually quite a clever way of highlighting the primary subject matter of the article, I suppose. But we're straying into graphic design now, and as you know, we're only qualified to talk about AWS and sheds. And
power tools.
and power tools, yeah, or non-power tools, manual tools. So let's move on. Another AWS blog post. We're heavy on the AWS blog today. We've got another article from the AWS Compute blog. And this one is about implementing reactive progress tracking for AWS Step Functions. Now, we all know, John, that you love serverless. So I'm sure you're going to wax lyrical about implementing reactive progress tracking for AWS Step Functions. I have to confess, I have not read this article in detail. I have no clue what it's all about. So I'm very keen to hear what you got to say on this one.
So this is actually something that I wish I'd known about 18 months ago, because I solved, or worked in a team that solved, this exact problem, but we did it slightly differently. This is a very nice solution, but it's a bit of a funny one. So, leading on from the previous topic about asynchronous workflow processing, one of the better ways of doing that is with serverless, particularly if it's like a low volume service, it's a new service, you don't want to have resources kind of spinning their wheels all the time. The problem with an asynchronous workflow is the caller of said workflow doesn't necessarily know when it's finished, but it might need the result of it when it's finished. Yeah, but why don't you make it a synchronous call then? Because otherwise you're just going to sit there kind of blocking things and spinning wheels and spending money when you don't necessarily need to. Excuse me. The example I like to use again is with user-generated content, because your calling process is probably an app or a website or something, and like the page abandonment time is 2-3 seconds. So you want to be able to upload thing into bucket and then let the user go off and do something else, rather than we're still processing, this is going to take 15 seconds. They're going to get bored and go away, and that's just going to break things. So put thing in bucket, go away and let the user do something else. We'll process this in the background. It might take us a couple of minutes. And the way we handled telling users that it was available through a progress bar at the time was by having a tracking table, Dynamo table, that the service would just poll every kind of 10 seconds or whatever to work out when it had finished, or to work out kind of how many pictures had been uploaded, 1 of 10, 2 of 10, whatever. This is doing it slightly differently. This is doing it through what's called a WebSocket API. We've spoken about these before, but a quick definition, a WebSocket API is it's like a continuous connection. Yeah, it doesn't have to be initiated by the client. It can be initiated by the server, and it just means that without all of the handshaking and all that jazz, data can move back and forth between server and client without having to re-authenticate and reconnect and all that. It's just a continuous connection. And what this basically means is through said WebSocket, the client can just be fed data. It's not request response. It's I've put this thing in here and I'm going to get fed the data, so I know how far through this system I am. That's a much neater solution. It really is. It's a much neater solution to this particular problem.
Cool. So now you know.
I'm going to tell my ex-colleagues about it.
Will you be using it? No, I don't think you should tell them about it. I think you should,
No, I will, because it'll give them an existential crisis.
No, I think you should offer to consult for them.
I can rebuild this. You know that thing that I built? I've got a better one. Do you want it for some money? No, John, go away. I can see uses for this.
I'm sure they're probably listening to the podcast anyway, so they now know all about it.
Hopefully. Yeah. Our 2 listeners.
No, that's me and you.
Oh dear.
So you were going to say you can see uses.
I can see uses for this. I don't have a particular use case for this right now, because a lot of the serverless work that I'm doing for our clients at the moment is kind of time driven, rather than having a client that needs to sort of track things. But I can see a use for this. Yeah.
Cool. So let's move on to the next article. And sticking with the AWS blog, again, the AWS Compute blog, we've got an article on how to create custom health checks for your Amazon EC2 auto scaling fleet. So what can you tell us about this one, John? Why might you need to do that?
So the example that they use in this is a custom health check based on a tag value on the instance to see whether it's passed or failed a compliance check. So that's kind of why you'd need to do it. They've sort of answered this. But let's start with some definitions and some why this is different and interesting. And then, excuse me, what did I eat for lunch? And then we can go from there. So normally there's one of 2 different types of health check that you use when evaluating the health of an auto-scaling fleet. If there's a load balancer in front of said auto-scaling fleet, you like to use a load balancer health check. And what that's doing is the load balancer is sending requests to a port, to a path, and expecting a known status code and a known response, 200 OK, with a response of alive or whatever, You can do EC2 status checks, which is just the server's there and it's available, or you can do custom status checks, which are neither of those, and it's kind of based on more or less whatever you like, within reason, based about the server. Why would you want to do something other than ELB or EC2? Well, because maybe you're provisioning the instance as it comes up and it takes longer than you can configure the health check to wait for argument's sake. Or maybe it could come up in one of 2 ways, and in some cases it will come up and it will be suitable to be used for certain processes and not for other processes. The example that they use here is a compliance check. So has whatever process that you need to ensure has it run? The last thing it does in that process is it updates the value of a tag to say, yes, I've finished successfully. But by default it hasn't. So that's kind of what you're using it for here, right? It's like an ALB health check, but you could use this in a world where you haven't got a load balancer in front of the scaling group. Like the first article, it's something's being brought online to process a queue, and obviously you can't use an ALB health check there because there isn't one. So you use a custom health check to say, yes, I'm bootstrapped. Now I can start processing.
So what sort of processes, give us a real world example of a type of process that you might be checking has completed in this
Like I say,
scenario?
it's the bootstrapping, it's the init script. It's that I've come up and I've done the correct things that I was supposed to do, but I'm not listening for traffic on a particular HTTP port. Like I say, it's like with the first example, with the first article that we had where it was processing things off of the queue. So it would be that kind of thing. It's that I've come up, I've bootstrapped, I'm provisioned, now I can start reading from the queue. Now you can mark me as healthy and not destroy me.
Cool. So the article goes on to describe how to do this. So if you actually wanted to go away and do this yourself, lots of code examples in the article, etc. So well worth a look. So moving on from the AWS Compute blog now, but not completely moving on from the AWS blog. Our next article is from the AWS News blog, and from your favorite purple-haired evangelist, Jeff Barr, telling us about some exciting new, super powerful Graviton 3-based general purpose instances that have been launched, the M7G and memory optimized R7G Amazon EC2 instances. So we're now on to the third generation of AWS's own silicon, Graviton 3. And these new instance types have got some pretty crazy specs as listed in the table. There we've got the M7G instances going up to 64 vCPUs and 256 gig of RAM. And the R7G instances going up to 64 vCPUs and 512 gig of RAM. So some pretty crazy performance from individual instances. Why might you need that, John? What might be the use cases for these new Graviton 3 instances?
Because you don't like money.
Yeah.
Those
M7G metals, I'm sure, are going to be pretty pricey. I haven't got the prices to hand actually, but yeah.
Yeah. So it's kind of sitting in the high performance compute space. I don't know I think AWS might have some HPC instances anyway, but it sort of sits in the high performance compute space. And what are you doing in high performance compute? You're doing 3D modeling and rendering in some cases. You're doing advanced AI and predictions. People predicting the weather are doing high performance compute. No, I'm not suggesting that BBC Weather or the Met Office or whoever it does it in the States is using these instances. They have their own supercomputers, but it's that kind of world. You know, it's large amounts of data crunching, large amounts of numbers coming through, being processed and coming out the other end, which is what these enormous instances are for, because they're enormous, and B, what ARM silicon is really good at. It's, as a general performance CPU, ARM is no better than 64-bit, 32-bit, x86, whatever you want to call it. Yeah, it's as a general, it's no better, and arguably in some cases it's a little bit worse as a general performance compute. But for really high input, output, and maths-based problems, it's very, very good. There's a reason that graphics cards are used for this in normal computer systems, because they run ARM chips, and they have done forever. They did for donkey's years. Because I don't know if you remember, but a little while ago now, Nvidia were in the news for trying to buy ARM, as in the people that don't make the chips, but like do the licensing and that kind of thing. And that was seen as a bit of a competition problem, because it would have been. But yeah, so there's a reason that like Bitcoin mining and whatever, that's done on ARM because it's very computationally intensive. So that's an interesting segue. If you see some of these in your account and you didn't put them there, they're mining Bitcoin for you. And someone else is taking your money.
Yeah. So speaking of money and maths-related problems, I did just reach for the calculator there and the AWS price list. So the M7G metal in US East Ohio region will set you back $2.61 per hour, which if you left that on for a month, you're looking at a bill of $1,880 a month. So these are not the sort of instances that you want to just forget about in your account. Unless you do have an enormous amount of money to burn. And if you don't want anybody standing up these instances in your account to mine Bitcoin, I suggest firstly making sure that your security posture is good. Failing that, at least get some budget alerts in place so that you know when they start to spend that sort of money.
The obvious thing to do is set a service control policy at the org level to ban these instances types from being used. Yeah.
Unless you need them. In which case,
unless of course you need them. If you need them, you need them. But I would argue that 95% of workloads in AWS don't need these. So whilst they're cool and we can wax lyrical about them and we can nerd out about how cool the architecture is, put an SCP in to block them.
Yeah. Yeah, and if you get in someone's way, you can always modify
turn it
the
off
policy.
again.
But
Yeah.
yeah.
That's absolutely generally, and veering away from the article a little bit there, that's generally something that people have come up against in historic terms, and it's why people are a bit reticent to do it now. But it's a lot easier to block something from happening and then get a request through and say, I actually need this. Okay, cool. There you go. And then block it from happening again, than it is to unwind an $1,800 bill.
The good news is, though, if you are caching your data in Sao Paulo, they're not available. Because if they were available, they'd be even more expensive in the most expensive AWS region. So, yeah.
London's more expensive than Ohio, isn't it? Or is it the same as Ohio? Because I know London's a bit more than the Americas.
I would imagine that London is more expensive than Ohio. The price I gave you was for the default region, which is Ohio. But yeah, let's have a look. What was it? M7G.
Yeah.
Oh, not available in London either. So.
No high performance compute for you financial shops then.
No, but it is available in Ireland, and it costs $2.91 an hour, which is significantly more.
Best part of $3 an hour. That's
yeah, which is over $2,000 a month. So there we are. Got to. These are not something to run up just to show your friends. You got to have a genuine use case.
Oh yeah, absolutely.
So, moving on to our final article of this week. This particular article on the news stack is combining something that we've spoken about on a number of occasions on the LogiCast podcast, sustainability and open source. The article is entitled AWS, Why We Support Sustainable Open Source. And we've talked about the two things in isolation before. Sustainability has been a regular thread of conversation on the podcast, and also AWS's commitment to open source. I think we've touched on, certainly I've touched on it in the news roundup before, and I think we've touched on it in the podcast. But here we are combining the two into sustainable open source. So what is sustainable open source, John?
I don't really know. It's a funny one because sustainability generally is just probably everyone knows what sustainability is, right? But it's just making sure that you're not using resources that you don't need to. You're turning things off, your solar panel, all that kind of stuff. Yeah. And then the open source side of things is just development done in the open. It's not anything too drastic. It's just, it's development done in the open. Sustainable open source, I suppose, is more talking about developer sustainability rather than environmental sustainability, because it's all fine and good at being an open source project, but if your people are burning out, yes, okay. Here's a common misconception actually about open source. You could be paid to write open source code. It's not altruistic particularly in and of itself. It's just development done in the open, right? There's actually an open source record of a number of UK government decisions around cloud and its usage available in their GitHub. It's just open source, right? So because it's open source doesn't necessarily mean it's free. It just means that the code's available. Doesn't necessarily mean that it's been worked on for free. It just means that the code's available in the open. So sustainable open source, I guess, is much more talking around developer sustainability, not burnout, no crunch time, all of that kind of thing. And they do, the ethereal they, like the Cloud Native Computing Foundation, the Kubernetes people, I like to call them because that's kind of what they're well known for, are quite good for this as well. Because again, yes, it's all open source, but people are paid to do it and they look after their people.
Got it.
Clear as mud.
So, yeah, no, I think I might have got the wrong end of the stick with the title of the article, actually, because I don't think it's about sustainability at all.
No.
Although it could be, but it's not. It's about the sustainability of the open source movement and spreading the load between multiple contributors and so on and so forth. The article does go on to talk about some of the well-known open source projects that AWS contributes towards. So things like Apache Airflow, Apache Cassandra, Java, Kubernetes, all things that we hear and talk about on a regular basis. But you're absolutely right. I think it's more about making sure that those communities are sustainable rather than the products themselves contributing to sustainability. Yeah.
It is an interesting one because open source has had kind of 3 major phases, and we're in phase 3 now. Phase 1 is sort of hobbyists and please pay attention to me. I'm desperately trying to be relevant. Phase 2 is and corporates not really trusting it. And phase 2 was mass adoption by the corporates of open source, like en masse. To AWS has spoken about this in the article as well. They have built huge swathes of their platform on top of open source, or by running open source things for you, like OpenSearch. OpenSearch is open source, and they are running it for you. So they have made enormous quantities of money and time has been spent on running and building and using open source. And then phase 3 is, please can we have some money so that we can actually keep doing the building that you're building on top of. So I think that's kind of what this is really trying to drive at and really trying to get at. Is up until really very recently, it went from we don't care about open source, we'll build it ourselves, to this is great, we don't have to build it ourselves, to maybe we should probably think about paying these people for what they've done, given that we've made $10 billion on it.
Yeah, AWS has suffered a lot of criticism for taking and commercializing a lot of these open source projects without really contributing back to it. So, this is another article in that vein where AWS is trying to show how much they are actually contributing back to the community rather than just profiting from it.
I don't know if this is a change of direction. I don't think this is a change of direction. I think this is more doubling down on what they were doing. But there's definitely been a shift since kind of the CEOs of Amazon and AWS have sort of all moved around a bit.
Yeah, for sure. I mean, to some extent, it's a bit of PR, isn't it? It's making sure that the critics are aware of what's going on, or it's an answer to the critics to say, you've made that criticism. Here's our version. Here's
our response.
Here's
our response that isn't a blog post titled "Setting the Record Straight," because that was terrible when they used to do that. That was awful.
Yeah. But I think this does a good job of setting the record straight. So, or certainly attempting to do so. So that brings us to the end of the articles for this week, and therefore to the end of episode 7 of season 2 of LogiCast. So we hope you've enjoyed listening to us waffling on for another half an hour. And we'll be back next week with another episode of LogiCast. Thank you, and see you next time.